So last lesson we did have a look at that, the idea that sine and cosine can be extended through to any angle, really, positive angles, negative angles, angles not just above 90 but above 180, above 360 even. All of those things are fair game as long as we think of sine, cosine and tan as being an angle in one of these four. Well, not, as long as we think of this angle as belonging to one of these four quadrants, and then acknowledging that we are going to assign a positive sign. We're going to make the trig function positive depending on what quadrant it ends in. So this is the cast diagram, or All Students Take Care, or South Australian Technical College, or that other one that I didn't like, what was it, about cats dying?
All sad turtles cry.
Oh, turtle, that's right, it wasn't cats. All sad turtles cry, which I thought was, I don't like that one. But it's called the cast diagram, as you can see. So this means that all trig functions are positive. The outputs to the trig functions are positive here. The output to sine is positive here, and the rest is negative. The output to tan is positive here, but the rest are negative. And the output to cosine is positive here, and the rest are negative. Okay, so if I end up with the sine of 271 degrees, that would be here, here, here to 270, and then one more degree. As soon as it hits into this section here, then we would have to conclude that the sine of 271 will be a negative value. I don't know what the value is, but it will be negative. All good? I haven't got any notes on this, but I might just quickly talk about it. Can you see how this is, remember how this line here is always of unit length 1? Or length of 1 unit, probably a more simple way of saying it. Remember that's how we defined it in the first place? That blue line is a length 1 unit line. Well, that might help you work out some of the boundaries that we haven't actually discussed yet. So I might just quickly switch it over to here and show you kind of what I mean with a nice big set of axes here. So 0 degrees would be along here, wouldn't it? Okay, so what do you think the sine of 0 would be? It's the xy coordinate, isn't it? So it would be 0. Yeah. Because there's no upwards or downwards. What about the cosine of 0? It's not 0. It's 1. Does that kind of make sense? It's 1 unit across the x-axis with no up and down motion, so it's straightforward 1 unit. What about the tan? Remember, tan was the gradient. Rise over run. So what's the tan of 0? 0. There's no rise, just a run. So that's one boundary, and it's certainly not a right angle property. Okay, let's go for a different colour. Again, 1 unit in length. Okay, let's go for that. What would the sine of 90 degrees be? One. Okay, it's 1 unit straight up. So the sine of 90 is 1. What's the cosine of 90? 0. No rise or run. What's the tan of 90? I'll give you that one. Do you know what D and E stands for? Yeah. It's not a real value. It's kind of got infinite run. Okay. I've got to choose colours. How about red, because it stands out. Okay, 1 unit long. What is the sine of 180 degrees? Starts with Z. Hello, Nix. What's the cosine of 180 degrees? Not quite, nearly. -1. Yeah? 1 backwards. What's the tan of 180 degrees? Rise over run, zilcho again. Is that okay? Is that making sense? Am I going too slowly? As usual? Okay, 1 unit length, but this time going down. What angle is that, by the way? Yeah. Sine of 270 is pointing straight down. So what's that? What's the sine of 270? Minus 1. What's the cosine of 270? Zippity. And what's the tan of 270? DNA. 0, but does not exist. Same reason. Okay? That's your basic 4 there. And then we can cycle through. So I won't write this down because then it gets messy. But if I said, what's the sine of 360? It's 0. The cosine of 360 is 1. Because we've got a full rotation, so we're basically back to this point again. Okay, so it's exactly the same values for sine of 360, cosine of 360, and tan of 360. Similarly, if I said 450, that would be basically all the way around, then standing up here again. So the sine of 450 degrees is 0, etc., etc. Is that okay? So they're the boundaries that I didn't talk about before. So it'll either be in one of those 4 quadrants or it'll be on one of those lines. Helen, question?
I'm wondering why the green's in 2 units instead of 1.
Yeah, because I'm an idiot. Just, in other words, the usual reason.
So if it's 1, okay.
Yeah. It's always unit length 1. Sam?
Do we always work in degrees or within switching radians?
We have been using degrees and radians a little bit interchangeably so far. We've done some work on radians, but when it comes to just thinking about stuff, because our brains are still switched over to degrees mostly, I didn't want to overburden what we're trying to translate in our head. But yes, we absolutely work in both, which you will see in these examples here. So just to go back then, so the cast diagram allows us to work out the SIGN sign, positive or negative. And so our general approach to solving a problem without a calculator is to work out what quadrant the angle will fall in, work out what the SIGN is, work out the acute angle, which is always formed between the x-axis and the line, and then solve it from there. Okay, so let's have a look at, I'm going to just zoom up on these examples here so you can see them a little bit more easily. If I could press the right button, that'd be good. So we've got 3 examples here. I'll get you to work through them we'll work through them as a class, and then I'll get you to do some work in the textbook. So 225 degrees. So the first thing I tend to do is I tend to draw a little set of axes, and I tend to just do a little spiral until I know where 225 degrees is. So where would 225 degrees end up? Quadrant 1, quadrant 2, quadrant 3, or quadrant 4? Quadrant 3. So what I would do is I would just go, okay, so it's going to go around here, and then I put my line in like that. Just a little rough note to myself so I've got a visual. Okay, all students take care, or cast, C-A-S-T, so will tan be positive or negative? Tan is positive, yeah. So remember, the letter represents it is positive there. Everything else is negative. Okay, so tan is positive. So now I work out what tan of the acute angle is. So what's the acute angle going to be? Well, remember I said that the angle is always taken from the x-axis. So I've gone 180 degrees here, and I heard someone mutter it, 45 degrees. So tan of 225 equals tan of 45. Okay, it's the same value, is what I'm saying. Okay, and then we get out our yellow information sheet. Note for video, in case you're not picking it up, what you're hearing is the sound of a lot of zippers. Actually, that sounds awkward, doesn't it? Of pencil cases or folders. I've got a couple of spares there. Okay. Tan of 45 is what? In radians? Anyone know just straight off? Yes, Sam?
Pi on 4.
Oh, you got it. Got it. Pi on 4. Yep. Pi on 4. So you're looking at the pi on 4 column, and you're going down to tan, and it says 1. Should be 1. Yeah. Done. Is that okay? Next one, tan of negative pi on 4. So I'm really saying tan of negative how many degrees? 45 degrees. So here, I draw it into my diagram. So there's negative 45 degrees there. That's negative pi on 4. I should label my angle. Just a really rough, remember this little diagram is an aid to you knowing, seeing what needs to be done. I really strongly recommend you do it. It's going to get more complicated with more diagrams later on in the unit, so get into the habit of doing it now. So you can see that it's in quadrant 4, so therefore tan is what in quadrant 4? Negative. Huh?
No.
You're causing trouble, Sam. So it's negative tan, and then the acute angle that's made, so theta hat is just pi on 4, that's just the acute angle. Okay? So negative tan pi on 4 is equal to negative 1. Does that make sense? So what quadrant is it in? What's the acute angle? What's the value of tan of that acute angle? That's your 3 basic steps. 19 pi on 4. Now, you don't have to reach for your calculator or work out too much. It's not so bad. 19 pi on 4. All we need to know is that a full rotation is 2 pi. Okay? I might do this, actually I'll just do it off to the side. No, there's no off to the side that I can do. So I'll just do it down here in a different colour. 2 pi is 1 rotation, and 2 pi has to be, 8 pi on 4. Okay? So all I'm doing really is I'm going to go, so 19 pi on 4 is equal to 8 pi plus another 8 pi, that gets me to 16, plus 3 pi on 4. 3/4 of a pi. Is that right? I think it is. Isabel? 2 pi is 1 rotation, okay? 360 degrees. As a fraction over 4, that would be 8 pi over 4, because 8 divided by 4 is 2. So if I'm looking for where is 19 pi on 4, I can see that 19 pi on 4 is 1 rotation, 2 rotations, and then this bit left over. Okay. If you're not too sure about that, just let me know later and I'll explain. Zooming up even more so I can just sort of show you. 1 rotation, 2 rotations. What?
Oh no, I was just
Maybe silly Jewish for a second.
Yeah. It's all good.
Now, that gets me the first 2, that's that and that done. The 3 pi on 4 is just not quite to pi, right? So, that's 0, that's pi on 2, that's pi, that's 3 pi on 2, okay? So 3/4 of pi will be somewhere in here. Probably best not, unless you're being serious, it's probably best not to keep putting me off.
No, I'm serious.
Okay, so pi on 4 is 45 degrees. What did you say?
135.
Oh yeah, good. Yeah, cool. 130. I thought you said 35 degrees. Does that make sense so far? I hope. If not, I'll come and talk to you personally, right? So I can just move on. So what we've done is we've got our little snail shell happening there. We've worked out that it ends up being in the second quadrant. Therefore, we know that tan is going to be positive, negative. It's only got 50-50.
Negative.
Negative, because it's only positive in these two. So, we're going to have negative. I'm going to do it sort of in 2 steps here. It's a bit squishy, I know. So it's going to be equal to negative tan, and then what have I got here? The angle between here and here is just another pi on 4. Okay? So it's negative tan pi on 4, negative tan 45 degrees, which is equal to negative 1. Okay, so because in every single diagram there, they all ended up being 45 degrees away from the x-axis, that means every single answer had the value of 1, and then it was just a matter of working out whether it was positive or negative. Okay, so again, what we're doing here is we're breaking down our angle into we're working out where our angle finishes, and then we're working out the acute angle between the x-axis and the line. And then we're applying a sine to it as well. Okay, I'll leave that there. We've got this question here. I'll pause the video and give you a chance to have a look at it. So I'm now telling you that theta is between 0 and 360, and I'm also telling you that sine of theta is equal to negative root 3 on 2. I've got a hint there on the right, but you might also be able to have a look at that chart that I gave you. That's in your information booklet. See if you can work out what theta is. I'll give you 2 minutes.
I don't understand. I'll give you 2 minutes.
Siri, there's so much you don't understand. Will asked the best question of the day so far. What was your question, Will? Are there multiple answers? And the answer is yes.
Because
There are multiple answers. So if you got 2 answers, very well done. Because remember, when I say solve sine theta equals negative root 3 on 2, I'm not saying find a value for theta. I'm saying find any values for theta so that that equation holds. Not just one value and then stop. It's any possible value. So the first thing to note is this. In the cast diagram, sine of theta is equal to negative root 3 on 2. Now we know the value is the thing that will give us the part of the answer in terms of the angle, but the sine is also part of the answer, because the fact that sine of theta is negative root 3 on 2 means that the angle must either be in this quadrant, because sine is negative there, or in this quadrant. It might be in one or it might be in both. The next thing we note is that in order to work out what theta is, we need to know the acute angle. So that means that it must either be here or here. And we need to work out what theta hat is. And because it's root 3 on 2, it's a specific value, it must be the same theta hat on both sides there. Okay? So it's either this angle or it's that angle. Okay? So the key to solving this is to working out what theta hat is. Now theta hat, or the sine of theta hat, is just the value without the sign. So step 1 is we go sine of the acute angle is equal to root 3 on 2. Therefore, theta hat is equal to, and this is where you need to know stuff, right? In a calculator section, you could just go sine inverse root 3 on 2. But in a non-calculator section, you need to know what that value is. So look at your information sheet, find root 3 on 2 in the sine row, and then go up and tell me what the angle is. Sorry? Pi on 3? So that's 60 degrees. Okay, note that my information sheet says pi on 3, but I'm just translating in my head as I go along to 60 degrees. Okay, so the acute angle is 60 degrees. Yeah.
If we take the answer in pi on 3, would that be?
I'll check it, but I would say it's bad practice. If it's asked for in degrees, then you should respond in degrees. But whether they would actually go, that's bad practice, but yes, you know what you're doing, full marks, I'm not sure. It's a good question. So therefore, theta, and this is why drawing this diagram is really helpful, because you've done the thinking about where theta will be, and then the next bit is actually you just referring back to the diagram to get it. So I'll just zoom up so you can see what I'm talking about. I now know that this is 60 degrees. So now if I follow my green, it's going to be 180 plus another 60. Okay, now you could just do this in your head obviously, but I'll just do it for the purpose of the notes. 180 plus 60, which equals 240 degrees, or theta equals what?
360 minus 60.
Good. 360 minus 60, which is equal to 300 degrees. Why wouldn't I go 0 minus 60?
Because it's 360 degrees. If it was 0, it would be equal to 7.
Yeah, because of the way we're rotating, that's true. But even more basic than that, because look at my range here, it's just 0 to 360. So negative 60 would be outside. So even though the sign of negative 60 is a solution, it's not a solution for the domain that I've been given. The range of inputs is just between 0 and 360. Okay, so that's why my answers are between 0. If I'd said theta is between 0 and 720, wonder how many solutions I'd have. Or between 0 and 90, how many solutions would I have? Or between 0 and 180, how many solutions would I have? So the domain is significant in working out how many possible solutions there are. Now, next week, we will devote more time to looking at solving equations, because there's some tricky things that can be done there. But I just wanted to leave the video here for today and just say I wanted to show you this simple equation solving, because effectively your scientific calculator would not be able to give you those answers. It might give you one of those answers, but it certainly would not give you both. So an understanding of the unit circle. See, when you chatter when I'm trying to talk, I'm sorry that it's boring you, but you're actually putting me off as well, making it even longer. Understanding the unit circle is critical to being able to work even with a calculator, to being able to work with these angles. Okay. All right, I'll leave the video there and we'll get on to some practice work for the rest of the lesson.